All right, let's take a look at the law of cosines. So the law of cosines is called such because it uses cosine rather than sine, which is what the law of sines uses. We also use it in different situations. There are three different formulas depending on what parts of the triangle you have. Notice it's also not used with right triangles. So here's our three different formulas we use. Again, capital B, and capital C represent the angles in the triangle. Lowercase a represents the side across from angle A. Lowercase b represents the side across the triangle from angle B. And lowercase c represents the length of the side across the triangle from angle C. Okay, so notice all of these lowercase letters, those are lengths of sides. The uppercase letters are angles. We can use the law of cosines when we have two side lengths and an included angle, or when we have all three sides. Those are the only two situations when you can use the law of cosines to find missing parts of a triangle. So again, it's either when you have two sides and an included angle, or if you have three sides. That's when we can use the law of cosines. We have an example down there. So let's take a look at it and kind of see how we work through a law of cosines problem. So here we have our triangle. Notice I have all three side lengths, and they're asking me to find one of the angles, specifically angle R. Okay, so I'm trying to find angle R. I want to know its angle measure. I have all three sides, which tells me automatically I have to use law of cosines. You cannot use law of sines if you don't know any of the angles. Okay, so when I set this up, notice the angle you're looking for, or the angle you're using. So like here, angle A was the one I was taking the cosine of, and it was equal to everything over here was equal to lowercase a. So when I start my formula, since I'm trying to find angle R, I'm going to start with, here's my little r, here's my little s, and this would be little t. Again, s across from big S, t across from little t. But since angle R is the one I'm looking for, and it's the one that I will have over here at the end of my formula, okay, I know over here at the other end I will be doing little r squared. So this is going to look like little r squared is equal to the other two sides. See, we have the other two lowercase letters squared individually. So that would be s squared plus t squared. Minus is what the formula does next, and then you have a 2. And here it's b and c, but notice it's the other two sides again. So those other two sides that I was not using the angle for. So this is what my formula is going to look like with R, S, and T. Again, I knew to use R here and here because that's the angle I was looking for. Now we substitute in any information that we know. Okay, do we know little r? Yes, it's 9. So we have 9 squared equals, do we know little s, the length of our side s? Yep, it's 7 squared plus little t is 4 squared minus 2 times, and then s and t, so 2 times 7 times 4. And then times the cosine of r. Now, I don't know what r is. That's what I'm trying to figure out, so it just stays capital R. I need to evaluate anything I can, so I'm going to do all of this multiplying. So 9 squared, and don't forget that squared means the number times itself, so 9 times 9 is 81. 7 times 7, 7 squared is 49. 4 squared, 4 times 4 is 16. Minus, I'm going to multiply these three numbers together. Okay, 2 times 7 times 4 gives me 56. So minus 56 times the cosine of r. Okay, we continue from here. I'm going to combine these like terms here. So I have a 49 and a 16. I'm going to go ahead and add those together. That gives me 65. So now I have 81 equals 65 minus 56 times the cosine of r. I'm going to subtract 65 from both sides of the equation. Okay, our goal here, what we're working towards, is getting r by itself. So I'm going to start over here at a positive 65. I'm going to subtract 65 from both sides of the equation. Okay, so 81 minus 65 gives me 16. That's equal to negative 56 times the cosine of r. Again, we're working on getting r completely by itself. I've noticed that it's the cosine is taken of r and it's multiplied by negative 56. We work our way from outside in. So times negative 56, I'm going to do the opposite, divide both sides by negative 56. Okay, well, what do we get? I'm going to have to run out of room. Move what I have left up here. So 16 divided by negative 56 gives me negative 0.2857 about, and that's equal to the cosine of r. Now leave that in your calculator because the less rounding we do, the better. In fact, I'm going to pull the calculator up here so we can take a look at it. So again, okay, so here we go. 16 divided by negative 16 divided by 56 negative. Sorry, I haven't used that calculator yet. Okay, so I put 16 divided by 56, and then I made the 56 negative. Okay, so again, there's my number, negative 0.2857. Now, where are we going to go from here? We have negative 0.2857 is equal to the cosine of r. Now, remember, when you don't know your cosine, how do you find it? You do the inverse cosine. So what I'm going to do to remove cosine from my r is do the inverse cosine of both sides. So I have the inverse cosine of that number that's still in my calculator would be equal to r, because again, when I do the inverse cosine, that cancels. Okay, so here I'm right there. I almost have my answer. I have my negative 0.285714. Just leave that in your calculator and do the inverse cosine. Again, make sure your calculator is set at degrees. Push inverse and then inverse cosine. And I get my answer. It's 106.6. Now, I don't remember if it said what to round to. Round to the nearest degree. 106.6 would make that round up to 107. So my answer is that angle R is 107 degrees. So I started by setting the whole thing up. I went off of what angle I was looking for, made sure the lowercase letter was at the other end of my equation, set it equal to the other two sides squared minus 2 times those other two sides times the cosine of my angle I was looking for, and then just slowly but surely went through each of the steps until I found my answer. Okay, let's take a look at an example here. An engineer suggests using a cable attached from the top of the Leaning Tower of Pisa to a point 44 meters from the base. Segment AB on the diagram. Okay, so here we have our diagram labeled. Here's our Leaning Tower of Pisa. How long would this cable be? Okay, so we want to know how long that cable is that's attaching. Let me get my line tool out here. How long is this cable from A to C? They want us to round the length to nearest tenth. It says, hint, you are given SAS. Select the correct law to solve the triangle. So look back in your notes. Hopefully you have in your notes, and if you don't, I'm going to write it down right now. Okay, so we had two different laws that have been introduced to us. We had the law of sines and the law of cosines. Okay, law of sines is used with more situations than the law of cosines. The law of cosines is only used with when you have SAS or SSS, two sides in the included angle, or just all three sides of the triangle. Law of sines is used when you have multiple angles, so ASA, AAS, and also the situation SSA. Okay, so this is when you would use law of sines if you have two angles in the side between, two angles and a side not between, or two sides and an angle that's not included. You use cosines if you have all three sides of the triangle, or if you have two sides and the angle between, which is the situation here. We have a side, and we have the angle between. So we are going to use the law of cosines here. Okay, so get that down. I'm going to erase those off so that we have room to work. All right, so we have our law of cosines. That's what we've decided we need to use here. I'm going to label the parts. They labeled the angles. Here's angle B, so we know across from that would be lowercase b. That's the side I'm looking for. Here's angle A. Across the figure from that would be our little a, and big C. Across from that would be little c. How do I know what to use in my law of cosines? Which of those formulas? Well, the angle you have, or the angle you're looking for, is the one you're going to do the cosine of on the end. And here, again, this is what law of cosines looks like. Okay, so since we have b, this is what it's going to look like. We're going to have our little b squared on this end, and our big B with the cosine on this end. So I know over here, again, on this end, I will have cosine of angle B, because I know